Well, is there a way to accomplish this task? Ah, the humble raspberry. It saves us again. That same ellagic acid compound we get from the raspberry that keeps the viruses from entering our cells also causes the DNA of bacteria to unspool. It turns out that all bacteria use an enzyme called gyrase to keep their DNA coiled, and ellagic acid inhibits this enzyme. Unlike antibiotics that only work on specific types of bacteria, ellagic acid inhibits all types of bacteria. Furthermore, since gyrase is not a human enzyme, inhibiting it is harmless to us. Now let's turn our attention to fungi and yeast. When people are infected with these microorganisms, they are literally molding, like a piece of bread or cheese left in the cupboard too long. Molds have been only a minor annoyance in the past 50 years, limiting themselves to ruining grain harvests and the occasional toenail infection. But times are changing. Toxic molds now commonly colonize houses and work environments, getting into walls and ceilings and ventilation systems. These molds can then transition into our lungs, where they may be impossible to eradicate. Chronic intestinal, fungal, and yeast infections are also on the rise. These intestinal infections bore holes in the mucosal membrane of the intestines, allowing undigested proteins to enter into the bloodstream, where allergic reactions ensue. Modern medicine has antifungal and anti-yeast medications, but the problem is that many of these are toxic to the liver and other organs. What would be useful is a way to attack these fungal and yeast infections without hurting our own cells. Is there some part of the life cycle of these two types of infections that we can inhibit without hurting ourselves? Well, it turns out that the same ellagic acid that stops viruses from entering our cells and causes bacteria to unravel their DNA also inhibits a key pathway in the life cycle of fungi and yeast. Fungi and yeast are types of plants, and so have a different type of cell wall than we do. Whereas our cell walls are made up of proteins and fats and are soft and pliable, their cell walls are made up of sugars, one of which is called chitin. This chitin is made with the help of an enzyme called chitin synthase 2, and fortunately for us, ellagic acid inhibits it. Without the ability to produce chitin, fungi and yeast cannot grow or reproduce, and given time, will die. And unlike common antifungal and anti-yeast drugs, ellagic acid has no known toxicity to our own cells. Since chitin synthase 2 is not a human enzyme, inhibiting it is harmless to us. The last type of infection to address is that of parasites. Many think that only third world inhabitants are at risk for parasites, but in fact, virtually everyone has some degree of parasitic infestation. Going to restaurants, owning animals, or traveling abroad virtually guarantees some degree of parasitic infestation. For the most part, parasites are happy to sit in your intestines and internal organs and slowly suck your blood. While there are many parasites that can kill a person, most parasites would rather suck as much life out of their host as they can without outright killing them. Parasites are the largest, smartest, and most evolved of the 4 infectious types, and so it makes sense that they have the best survival strategies. Unfortunately, most antiparasitic drugs have side effects worse than the symptoms of the original parasite itself. Is there some way we can deal with parasitic infections without hurting ourselves in the process? Again, ellagic acid and the raspberry come to our rescue. While the exact mechanism of how ellagic acid kills parasites is not fully known, it has proven itself against a number of different parasites. Current scientific thought suggests it has something to do with the glutathione reductase pathway, but that is beyond the scope of this presentation. This concludes our discussion regarding how ellagic acid can be used to suppress viruses, bacteria, fungi, yeast, and parasites. There is one more condition that ellagic acid has shown positive results with that we will discuss here, and that is cancer. In fact, if you look in the scientific literature, ellagic acid is better known for its ability to fight cancer than anything else. While there are several different ways in which ellagic acid both protects against cancer and helps fight against cancers that have already formed, the one we will discuss here is its ability to cause cancer cells to self-destruct. The technical term for this is apoptosis. Whenever a cell becomes cancerous, our DNA sends it a signal to self-destruct. This is one of the most powerful safeguards we have in preventing cancer, and it works the majority of the time. Unfortunately, it only takes one cancer cell capable of blocking this signal for a tumor to form. It is specifically those cells that are capable of overriding the self-destruct signal from the DNA that continue to grow and eventually form tumors. What ellagic acid does is to powerfully reinstate the self-destruct signal in cancerous and precancerous cells. Unlike chemotherapy, which damages healthy and cancerous cells alike, apoptosis, or cell self-destruction, only applies to cancer cells and other damaged cells that are no longer useful or safe to have in the body. There are other ways in which ellagic acid supports the body in dealing with cancer, including protecting our DNA from mutagenic chemicals, causing the growth cycle arrest of cancer cells, and protecting the cellular regulatory gene p53, but again, these are beyond the scope of this presentation. Ellagic acid is truly a remarkable compound. It inhibits viruses, bacteria, fungi, yeast, and parasites. It helps support the body in its fight against cancer. Ellagic acid is truly the one thing you would take with you to the proverbial deserted island. I hope this information has been useful for you. For more information about ellagic acid, or to order Ellagica, a USP-grade ellagic acid supplement, contact the healthcare provider who gave you this CD.